The size of the orbital will increase. What implication does this have? So you have the orbital size increase, and therefore effectiveness of your orbital overlap with the 1s orbital of H will decrease. Why is it so? You need to understand one thing about orbital overlap, right? So for covalent bonds orbital overlap is most effective when the sizes and the orbital energy is similar. So for orbital size and orbital energy level, the more similar the size and energy level, the better the overlap. Now think about 1s. So for 1s orbital, Cl, Br, and I, the valence orbital of the halogens, the energy level will increase and will get further and further away from the 1s orbital of H. And this is exactly why the effectiveness of orbital overlap between the halogen valence orbital and the 1s orbital of H will decrease, because the energy gap between the orbitals are getting further and further apart. So if orbital overlap effectiveness decrease and covalent bonding is defined by overlapping of orbitals between bonding atoms leading to the sharing of electrons. So if effectiveness of orbital overlap decrease, that means the covalent bond that is formed, will it be stronger or weaker? So the less effective the orbital overlap, the HX bond becomes longer and weaker. Okay, down the group, the size of the halogen atom increase. The orbital size will definitely increase. Bond length will increase from Cl to Br to I, and therefore bond becomes longer and weaker, and less energy will be required to break the HX bond. Bond strength decrease. Bond length increase, but bond strength decrease. Bond length and bond strength is that they have an inverse relationship. So the longer the bond, the weaker the bond. The shorter the bond, the stronger the bond.